His name is Marc Jadoul. He is the Market Strategist Director at Nokia. Marc, welcome, and the floor is yours.
So I assume I can start presenting. So
Yes.
Good afternoon. I'm Marc Jadoul from Nokia, and let me share my presentation. So, good afternoon again. In the next 15 minutes, I'm going to tell you about 3 related topics. Of course, as the subject of today is digital transformation, I'm going to talk about digital transformation, but I'm going to talk about industrial use cases. Then I'm going to introduce the role that the network plays. In this case, I'm going to talk about 4G and 5th generation mobile communications under the form of private wireless networks. And then, as a case study, I'm going to explore the mining industry, which is a growing industry and an important economical sector for many African countries. And we look at the mining industry and some other physical industries from a transformation point of view, from a digital transformation point of view. I think there is a significant difference with some of the use cases and the topics that you have presented earlier today, because mining industry, like other industries, I'm thinking of ports and manufacturing, is an industry which is what we call asset intensive. You can just use software for digitizing. Let's take an example, the banking or e-commerce. This is an IT activity. This is a software-based transformation. But if you are looking to, in this case, the mining sector, they are dealing with a huge amount of physical assets. Just think of all the monster trucks with wheels that are 2 meters high, that are running across the mine. Think of loaders and all the other equipment. And in this transformation case, you can't just say, let's take out all the physical assets and replace them by software or by an IT system, which means that digitalization actually goes in 2 phases. First phase is that you're going to equip these digital assets with sensors, with a number of tracking functions, that actually you can create a real-time digital view of these physical assets. And this allows you, for example, to continuously check the tire condition of the trucks that are driving in the mine, or to monitor the physical condition or the fatigue of the truck driver. You can imagine a guy who is driving a 300-ton truck. If he gets tired and he's losing his attention, that some heavy accidents may happen. So it's also important not only to monitor the vehicle, but also to monitor the driver. So this is where you're going to add data and real-time data to the physical assets. And then in a third stage, you are going to use your system actually to digitally control the physical assets. And then coming back to the mining example with the trucks, then we are entering in scenarios where we have tele-remote operated trucks, and there are some examples of mines that are actually driving their trucks with the joystick from a distance of more than 1,000 kilometers, or you can even go to fully autonomously driving trucks and cars. So mining is just one example, but there are tons of other examples of what we call asset-intensive industries, where you can't just replace the physical by digital, and where the physical and digital will complement each other. I'm thinking, for example, of power utilities. You can't generate electricity without some physical assets. Thinking of airport operations, you can't have an airport without planes and without airfield workers that need to communicate. You have the maintenance crew and the cleaning crews, and it's a big collaboration project of people and assets. Other examples are ports, container terminals, manufacturing. Again, you can't manufacturing physical things without machines or without robots. And then the sector I'm going to focus on today is mining. Now, why is automation in mining an important topic? Well, just look at what are the key performance indicators, the KPIs of the mining industry. And if you ask any mining operator or executive of a mining company, the first thing they will always say is people safety. The fact that you have people working in harsh and dangerous environments, that they are maybe confronted with these 300-ton trucks, means that you have really to take every possible measure to keep the assets and the people as far away from each other to create a safer working environment. The second important factor is improved productivity. And productivity, it's very easy to express in a mining context, is the tons of ore or the carats of diamond or gold you are getting out of the mine. This is the productivity. Then we're talking about the third parameter, which is efficiency, or you could also call it profitability. This is actually the tons or the carats you're getting out over a certain time span. Let's say the tons per day. And actually, as we will see a bit later in this presentation, these three are really very closely connected. If you have a safety incident in a mine, very likely you will have to stop the truck or even halt the production, which will impact the productivity. Take a copper or an iron mine. If you have to halt the productivity for a few hours, you're really going to lose a production of several tons. And then if you're losing productivity, of course, this is going to weigh on your top line and or your bottom line, and this is going to impact profitability. And then the fourth KPI, which is coming more and more in the game, is sustainability. Mining is really becoming one of the sectors where there is a big focus on saving energy and implementing clean operational practices. Now, on the left-hand side of the slide, you actually see a graph that I have borrowed from Sandvik, which is one of the key automation players in the mining industry. And if you look to the colors, then you see that the gray is, remember the first slide I showed, this is the manual operations mode. And what you see is that there are spikes. The spikes are the working shift, and you see that there is probably a lunch break, and that at night they don't work. It's not a continuous shift because you can't work when it's dark outside doing this dangerous business. So secondly, then you bring in information, you augment your physical assets with data collection, with real-time data, and what you see is that you're entering in the orange zone where you are actually improving productivity, where you are improving efficiency because you know what's happening and you have full insight into your operations. And then when you are bringing in the third one is automated control of these assets, then you're entering really in the productivity area, in the light blue one, because then you can move into a model of a 24/7 continuous operation, for example, with autonomous vehicles or unmanned trucks. Now, if you want to run these applications and these digital applications, sometimes at a distance of 100 kilometers when they are remote controlled, you need network technology. And you can imagine that in a mine environment that you can't just rely on putting cables in the mine because they will be cut within a few minutes if one of these vehicles is driving over with them. So you need to look for wireless technology. And what we see that in mining environments, often Wi-Fi is still the standard being used. But those who are coming from the IT sector know that Wi-Fi was actually a technology that was designed for indoor environments, office environments, IT applications. And actually, Wi-Fi hasn't been designed for harsh mining environments, where there are, if it's underground, where you have to deal with narrow drifts and thick rock walls, where you have a mine geography that is continuously changing, where you have tremblings caused by explosions and drilling, which means that you need a network that is much more reliable and stable and robust than current Wi-Fi technology. And this is where private 4 and 5G networks are coming in. Most of us have been dealing with mobile phones, first 3G, 4G, now entering the 5G era for the past 10 or 15 years. And we all know that this is what we call a carrier-grade reliable technology. And what we are doing at Nokia is we are putting these 4 and 5G networks in industrial environments as standalone networks or either connected to the cloud. And on this slide, I'm not going into detail, but you see some of the comparisons of the key indicators of Wi-Fi technology evolving from Wi-Fi 5 to Wi-Fi 6 and how private wireless is actually performing much better and is much more robust than putting a Wi-Fi network in a mine. So a bit about the evolution from 4G to 5G, because the title mentioned 5G. We started with 4G, and 4G was really deployed as a broadband-only network. Thanks to standards evolution and optimization of technology and combination of different spectrum frequencies to obtain more bandwidth, 4G has become a much more powerful network. This is why we're calling it 4.9G. And 4.9G actually supports broadband communications with very high speeds, also supports industrial IoT applications, low power sensor networks, and highly demanding critical machine communications. When we talk about machine communications, we are talking about a necessity for high reliability and low latency, low delay. You can't, for example, control a truck, or you can't remotely control a robot if you have a turnaround time of let's say 20 or 25 milliseconds. And then we're further evolving into the 5G standards, and 5G is going to offer even higher bandwidth, more connected devices. You can connect millions of devices simultaneously to the network, and is adding some additional industrial features like reliability, latency, security. Now, while 5G is hitting the consumer market, I recently bought a 5G phone at the corner of the street. The industrial ecosystem is always lagging a bit behind, because you have to deal with industrial chipsets, you have to deal with ruggedized industrial devices. And what we see today is that many industries, including mining, are making the transition from 4.9G to 5G. And while 4.9G is already offering, let's say, support of 85% of industrial applications like remote control and autonomous driving, 5G will offer more bandwidth to support ultra high definition video and really millisecond latency for remote machine control. Now, I'm going to show you a short video.
Nokia industrial-grade private wireless is powering Industry 4.0 today and the 5G revolution tomorrow. Your own dedicated network, connecting everything, person, and data point, and untethering endless possibilities. Automating and improving mining operations requires connectivity beyond Wi-Fi and professional mobile radio. Nokia Private Wireless provides reliable, secure, low-latency connectivity that unearths peak productivity and automation, total situational awareness, and mission-critical communications for remote operations. Let's dig a little deeper. With 360-degree situational awareness, you can get the widest possible picture of safety and sustainability. Connect machinery, vehicles, staff, and IoT sensors for remote health and safety monitoring. Get data from sensors, cameras, drones, and more, and use video feed analytics to remove workers from hazard. Autonomous vehicles push all the right buttons for productivity, efficiency, and safety. Power autonomous drilling and hauling for 24/7 operations. Use AI and predictive alerts to avoid obstacles, while monitoring remote automated operations in real time. Nokia industrial-grade private wireless, powering the new age of mining and every other industry from now to next. Nokia.
So, just case study showing the big difference between.
All right. For the interest of time, Mark, let me just interrupt you there for a second. We just have welcome the next speaker. Yes. So you just have about a couple of minutes to go, just so that we do catch up with lost time.
So can I continue presenting?
Yes, so about 2 minutes or so. Is that okay?
Yeah, I will keep it short. Just on this slide, I'm showing a use case with numbers we actually got from Komatsu, which is one of the major suppliers of these big mining trucks for open pit mines. And as you see, in terms of communication errors and in terms of lost connectivity, there is a huge difference. And as I told you, you have low latency, you have high bitrate, you have IoT connectivity. This means that actually the same network can host all mining applications, going from the one that really need high capacity, even drones with video cameras, over mission critical communications, walkie-talkie can push to talk, push to video services, IoT and analytics, worker health and safety monitoring, and everything that comes between. And as Steve Jobs used to say, one more thing, it's actually the same technology, the same network technology that can be used above and underground, which means that if you have a mine operator that is operating both an open pit network and an underground network, you can actually use the same core, the same technology with some different antennas, but operate all mines with one network technology. So if you're looking for some more information, here are two links. The industry's links points to the broader story about private wireless. If you're looking specifically for mining use cases and information, go to the link below. So thank you very much. I hope this was a bit interesting for you. And it's Marc.
Thank you so much, Marc. If any questions do come through on the platform, we will direct them to you, and hopefully there'll probably be a connection between yourself and whoever's asking the question so they could get the answer for it. Thank you so much to Marc for giving that very insightful presentation. That is Marc Jadoul, who is from Nokia.